sir.
Yes, sir.
Okay, so till now we have discussed many things. We talked about Nernst equation, okay, and where to use. We talked about E naught cell, okay. We talked about other all the things like how to calculate reduction potential, how to calculate oxidation potential, and electrochemical series. Many things we talked about, and this type of electrodes we talked about, right? Metal electrode, gas ion electrode, amalgam. Okay, metal amalgam and metal insoluble. So this is not there actually for you. This two is not there. Calomel electrode, oxidation reduction half cell, that what we are using. Okay, that is nothing but oxidation. One side oxidation is there, one side reduction is there. And we have started electrolysis. Okay, so we talked about concentration cell. I told you what is concentration cell. Then what is concentration cell? Tell.
When same
Tell. Tell what is
same element
ah,
goes
same element of what?
electrode. Same element of electrode is taken for both sides.
Next. Then
Only the concentration will be different.
so anode and cathode both will be same, right? Anode, cathode will have same element, just only the concentration will be different. Now we talked about electrolytic cell. What is electrolytic cell? Electrolytic cell means electricity will pass through to do non-spontaneous reaction, right? So you know spontaneous reaction having delta G negative, okay, and non-spontaneous reaction delta G positive, right? So for that reaction, if you wanted to do how much electricity you have to pass, or that if you have to pass electricity, that is electrolytic cell. And we talked about Faraday's law. I'll go with that. We'll recap that also. Two laws are there. Faraday's law, like whenever electrolytic cell is there, some some amount of gas will evolve, okay, or some amount of metal will deposit. Okay, we'll talk about that when metal will deposit and when gas will evolve. That also we'll talk. So, first of all, today also this is an important topic, that electrolytic conduction versus metallic conduction. Hmm. Electrolytic conduction versus metallic conduction. So, what is electrolytic and metallic conduction? Like metal also do conduct electricity, yes or no? Metal also conduct electricity. So, so concentration. Now here we talked about this. This also very important. I told you that for concentration cell, that whatever the anode side is there, if you are doing like this, okay. So this side is anode and this side is cathode. Yes or no?
Yes.
So what side you are taking, and after that Nernst equation, overall E cell value should be negative. Why overall E cell value should be negative? Because delta G should be negative. Yes or no? Hello. Delta G should be negative. So delta G is equals to, we know, minus NFE. So this E value should be positive. How this E value will be positive? When P1 is more than P2. Okay, this is for hydrogen gas. Remember this thing, very important. For hydrogen electrode, when you are using, then you can say that P1 more than P2. But when you are using chlorine, okay, remember when the reaction written like this, platinum, chlorine, P1, okay, and Cl minus, then aqueous, then salt bridge, and then chlorine minus, and Cl2, and then this is P2, and after that platinum. When chlorine there, okay, then what will happen? Then everything will change actually. Then what will happen? See.
So can you go to the previous slide for 1 second? I have it over there.
Tell.
Left side will be anode. You wrote reduction here.
Which one? This one.
Cl2. Yes.
This you need to understood this thing. See, platinum when I'm doing like this, Cl2 Cl minus, okay, and this Cl minus Cl2. Now when I'm writing this, if left side anode, very good, correct, is left side anode. So if left side anode, this is written like this, but you have to write the anodic reaction. What is the oxidation reaction? So what will be the oxidation reaction? Cl minus plus, sorry, Cl minus will give Cl2. This is oxidation, yes or no?
Yes, sir.
Plus here you can
Two electrons.
2 electron. Okay, 2 Cl minus. So this is oxidation. This you have to write. Now they are written what? This is pressure 1, concentration 1, yes or no? Or I can write pressure of the anode and concentration of the anode. And this side pressure of the cathode, sorry, this will be concentration of the cathode and pressure of the cathode, yes or no?
Yes.
Yes, sir.
Now this is anode reaction. Now what is the cathode reaction then? Oxidation. Cathode reaction, reduction. So reduction will be Cl2 plus 2 electron will give 2 Cl minus, yes or no?
Yes, sir.
Now what is the overall reaction? Overall reaction we have to check. So overall reaction will be 2 Cl minus plus Cl2 will give Cl2 plus 2 Cl minus. Now remember this thing, very important. What is this? This is Ca. This is Pa. Yes or no? For this concentration of anode will be given and pressure of the anode side will be given, yes or no?
Yes, sir.
And for this pressure of cathode and concentration of cathode will be given. Understood?
Yes, sir. Understood.
Now see which side what is there. This is concentration of anode and pressure of cathode, and this is pressure of anode and concentration of cathode. Clear? Which you call, this is C1, this is P2, this is C2, sorry, this is P1, C2. Understood?
Yes, sir.
Yes, sir.
Now write the Nernst equation. Simple. E is equals to E naught value 0. You know, for concentration cell, E naught value 0 minus 0.059 or 0.06 divided by n value. I am not writing 2 because n value will change. Okay, here it is 2. Log, tell me, in the upside who will be there? Product.
Yes, sir.
Correct.
So product, Cl, concentration of Cl minus into concentration of Cl2
Power to
divided by concentration of Cl2 into concentration of Cl minus. So what you can write? Minus 0.059 divided by n log Cl minus which concentration? This concentration. So C2 square into P1 divided by C1 square into P2. Clear this thing? So
yes.
Yes,
if C1, C2 equal to 1, then we have to check. So for this, remember, for chlorine, what will happen? P2 should be more than P1 and C1 should be more than C2. Clear? Okay.
yes, sir.
But for hydrogen, what is there? Hydrogen P1 should be more than P2 or P anode should be more than P cathode. Okay. P anode should be more than P cathode and C cathode should be more than C anode. They are completely reversed. So whatever reaction given, no need to worry. What you have to do, first do this thing, reaction written. Write the reaction by seeing whatever this should be written like this. This is the writing formula to write any cell representation. That is the rule, right? First you have to write the electrode, then you have to write the electrolyte and the electrolyte what we are using, gas, and then electrolyte what you are using. Clear? So Cl, it is not means that if it is written in the left side, that means Cl2 to Cl minus. No, anode side always written in the left side. Okay, and if it is written means there will be oxidation. Clear? So oxidation reaction you have to write. Understood? Okay, so go ahead. Tell me. Hmm. What about Sarvesh? How are you?
Sir,
Tell. Are you okay?
yes, sir.
What happened?
Because I have a little bit stomach upset.
Oh, okay, go ahead.
Sir, option
Option A. Anyone else?
So B.
B. Tell. A, B, plus or minus. Think about it. I'll tell you which one is more. But without pen, I can solve. Which one is more? P1 is more or P2 is more?
P1 is more.
P1 more. P1 is equals to 10 into P2, right? So if P1 is more, obviously E value will come in positive. Yes or no? Yes or no? Simple. Simple. My thing is that if P1 is more, obviously E value will come in positive. Okay. So positive value. So automatically option B, option D gone. Now what is the value? 0.03 or 0.06 that you need.
0.0.
Okay. So
Yes.
0.03. Clear? So 0.06 by 2 log P2 by P1. 0. So 0.1 10 per minus 1 unit. Okay. 2 why 2 came, you understood? Simply
Yes,
H2
sir.
plus 2 electron. Clear?
Yes, sir.
Okay. Next. Let's see. You can tell. Is also concentration cell. When delta G will be negative.
Sir, option C.
Option C. Okay. Anyone else? What happened? Sarvesh. Simple thing. We know what will happen. This is reactant. This is product. This is reactant. This is product. Is on. So we know reactant by product. So C2 by C1 will come. So obviously C1 should be more than C2. Yes or no?
Yes.
Sir, C.
Tell.
C1 by C2 will come.
Oh, sorry. Product by reactant by product. So C1 by C2. So
So
C2 molecule. Okay. So this is the thing. Next. Tell. Understood? Last question. Understood or not? Tell.
this
Note down this question. Go ahead. Not that much time. Noted. Note down the question. Question should be in your note. Telling the EMF of a concentration cell consisting of two zinc electrode, one dipping into M/4 solution of zinc sulfate, another one is M/16 solution of the same salt. Okay. Now you have to find out the E cell. Okay. Note down the question and just tell. Tell. What about others? Simple thing, zinc sulfate, Zn2 plus concentration given. Okay. Yes or no? Two zinc electron, one is dipping this and this. You know that always the E is equals to minus 0.06 by 2. For this case 2 log of low concentration by high concentration. Okay. So low concentration, which one is low concentration? M/16 is the low concentration.
M/16.
So M/16, yes or no? M/16 into high concentration multiplied with M/4, yes or no? So clear or no? This will cut. So 0.06 by 2 into log 4. Now log 4 means what? I can write log 4 equal to log 2 square. So log 2 square means 2 log 2. Yes or no? So I write 0.06 by 2 multiplied with 2 log 2. Now log 2 value is 0.3. Remember this. Log 2 value 0.3. So 2 and 2 cut, 0.06 into 0.03. Okay. Whatever value you will get, that will be the answer. Okay. So 0.3.
Sir, where did the minus sign?
0.3. Where minus sign? Where? Array. Log 1 by 4 you are coming, na? Log 1 by 4 you are coming. So if you log 1 by 4 means minus log 4. Yes or no? So minus will become plus. Okay.
Yes, sir.
So that is how you will get clear. So around 0.178. Okay. So log 4 value around 0.6. Okay. 2 log 2 na. So 0.6. So 0.6 into 0. Whatever. This they took 0.15. So close to this. Clear?
Yes, sir.
Understood this thing? Yes or no? Tell. Sarvesh Ashmita.
Yes, sir.
Okay. Next is electrolytic cell. We have started electrolytic cell. Okay, but I told that in one half cell we are doing this electrolytic cell. Okay, any side you can take, anode, cathode, any side you can put, doesn't matter. But same thing here, cathode means reduction and anode means oxidation. But in this case, what happened? Anode is positively charged and cathode is negatively charged. Sometime question will ask, sir, electron flow which side to which side? Remember, electrolytic cell or galvanic voltaic cell, whatever cell, electron always go from anode to cathode, always. And where electron will go? From outside of the circuit. From outside of the circuit, electron will flow. Okay, any kind of cell you take, always it will go anode to cathode. Okay, because oxidation happen. Oxidation means what? Loss of electron. So where loss of electron, it will give the electron, right? So this is the thing. But here charge is different. Why charge is different? Because anode is added to the positive side of the battery and cathode is added to the negative side of the battery. Okay, now there are many type of cells will be there. Simple thing, remember, if you are taking any molten, if you are taking any molten salt, for example, if you are taking molten NaCl, okay, molten NaCl. Now in molten NaCl, what are ions are there? Na plus ion and Cl minus ion. Water is not there, right? Yes or no? Na plus ion, Cl minus ion. Water is not there. So if water is not there, tell me, with in anode what deposition will be there, and in cathode what deposition will
In anode, Cl minus. Cathode.
be? No.
Sorry.
Anode means oxidation. Yes or no? So who will get oxidized? Na plus will get oxidized. Not possible. Yes or no?
Friend, anode Cl minus will.
Cl minus deposit Cl2 you will get, right? In anode,
Yes,
what
sir,
you will
yes,
get?
yes, sir.
You will get Cl2, right? Yes or no?
Yes, sir.
And cathode, what you will get? Sodium. Okay, sodium metal will deposit. Understood? If molten NaCl is there, but if aqueous NaCl is there, if there is aqueous NaCl, then what will happen? Then the thing is that simply how many ions are there? Na plus there, H plus there, Cl minus there, OH minus there. Okay. Now H plus is smaller than Na plus. Yes or no? H plus is smaller than Na plus. Okay. Chemical bonding you learn that H plus small now. Hydrogen is smaller than sodium.
Yes, sir.
So who will go fast towards electrode? Obviously H plus.
Yes,
Or
sir.
else remember like this. Don't remember like this smaller or else. Tell me who have reduction value, E naught reduction value more.
Na.
Na. Sodium more reduction
Sorry,
value.
sorry.
Sodium having negative value, whereas hydrogen having 0. Yes or no?
Yes, hydrogen.
So who have more? Obviously this. So easily it can get oxidized. Yes or no? Sorry, easily it can get reduced. Who have more reduction value? So I told you your electrochemical series. More reduction value, good oxidizing agent means easily it can get reduced, right? More reduction up to down, more reduction value. Okay, more reduction value, good oxidizing agent. Good oxidizing agent means less electropositive element. Okay, and easily get oxidized, easily get reduced, easily reducible. Clear? Yes or no?
Yes, sir.
Okay, so who will easily get reduced? H plus. So if H plus easily get reduced, so in the cathode instead of sodium, we will get hydrogen. And if you check the electrochemical series between chlorine and oxygen, chlorine having more, yes or no?
Yes, sir.
Chlorine having more. So chlorine get between chlorine and oxygen, chlorine having less actually. Okay, so that's why it will get easily oxidized. That's why it will get easily oxidized if you check the value. Okay, so it will get easily oxidized. So when it will get easily oxidized, so we will get chlorine gas in the anode. So molten NaCl you will get chlorine and sodium, but aqueous NaCl you will get chlorine and hydrogen. Clear this thing? Tell this thing very important. Okay, see, whenever this is given, just you have to write which ions are there by comparing the E naught value. Okay, direct value you don't need. Sometimes value also given. No need value direct. Okay, you have to see that which one having more E naught reduction value. Okay, so who have more E naught reduction, it can easily reducible. So here H plus having more reduction value, so easily reducible, so it will go to cathode and hydrogen, produce hydrogen gas instead of sodium. Clear? And between chlorine and OH, who have more reduction value, OH minus than chlorine. So chlorine will get easily oxidized, so it will go to anode. Clear? Understood?
Yes.
Next, another one. If I take only water, then what will happen? We'll get hydrogen gas in the cathode and oxygen gas in the anode. Yes or no? Hydrogen gas in the cathode, oxygen gas in the anode. Achha, let's suppose I am taking aqueous CuSO4, copper sulfate. Very important. Now, here problem is there. Sir, here ions, which ions are there? Cu2 plus is there, SO4 2 minus is there, H plus is there, OH minus is there. Now, you know who have more reduction value, copper or hydrogen? Wrong. Hydrogen is 0.0 and copper is 0.34, positive value. Okay.
Okay.
Reactivity order. Go through the electrochemical series. Reactivity order is there. Okay. If you forget, just remember like this. Okay. Lucy, please stop calling me. Okay. Me, a cute zebra. I like to call. I like her calling me a smart guy pilot. Okay. So remember, highest like lowest negative value or highest reducing power having lithium. Lucy means lithium. Okay. Then please means potassium. Then sodium. Then calcium. Okay. Hello.
Yes, sir.
Why it's not going on? Okay. So one by one, just say. So lithium, then sodium, then lithium, potassium, sodium, calcium. Then Me means till magnesium. Okay. A for aluminum. C for carbon, zinc, iron. Like means lead. Okay. And her means hydrogen. Then after that, calling means copper. Then Me means mercury. A means your calling me. A means not calling me A. Calling me smart guy. But smart means silver, then gold, then platinum. Okay. So this is the order you should remember. Yes. So where we are? So this now obviously this one having more reduction value. Okay. Copper having more reduction value. So more reduction value means who will deposit in cathode? Copper.
Okay.
And SO4 and OH minus. SO4 and OH minus. SO4 minus having more reduction value. So who will deposit in the anode? Oxygen. Understood? So just remember, in anode, chlorine, fluorine, bromine, iodine. if they are, then it will deposit. Except in any of them, anything is there, oxygen will deposit. And in cathode, you have to check whoever above hydrogen, if they are there, then hydrogen will deposit. Whoever below hydrogen, then that metal will deposit. So lithium, potassium, sodium, calcium, for magnesium, aluminum, carbon, zebra for zinc, iron, lead, hydrogen, copper, mercury, and silver, gold, iron, platinum. Okay, so whoever, this is downside. Okay, written here, but this is actually after mercury. Okay, so after mercury.
Yes, sir.
After mercury. Okay, so whoever, if upside any metal is there, hydrogen will deposit, hydrogen gas you will get. If downside hydrogen is there, then that metal will deposit. Clear? This thing remember, very.
Yes, sir.
Okay.
Understood.
Happening today. Okay, so this is the thing. Next, let's go for a question. Tell. Option 12.
B.
Anode to cathode through internals.
Internal supply or external supply?
External.
External supply. Okay. See, if you're talking about internal supply, then cathode to anode. External supply, anode to cathode. Okay. Clear? This actually generally no need to do. Go for this. Delta G for an electrolytic cell.
Positive.
Positive for an electrolytic cell, delta G will be positive. Next, go ahead.
Option D.
Process is non-spontaneous. Okay. Next. Well,
Question. No question.
okay. Understood and out?
Sir.
Now coming to electrolytic and metallic conduction. See, metals conduct electricity. Why? Simple, it have free electrons. All the metals having free electrons. Most of the metal having free electrons. Sodium, potassium having one free electron. Okay, iron, 4 electron free. Okay, valence electrons are free electron. Okay, so the more number of valence electron, more conductance is there. Okay, also metallic conduction is inversely proportional to temperature. Why? Temperature, if you increase the temperature, the metallic conduction will be decreased. Why? Simple thing. Simple thing. I told you this also. Like, let's suppose you are standing here and you are going this side. Okay, you are standing here, you are going this side, A to B. Simply, if I increase the temperature means, let's suppose here molecules are there or people are there. If I increase temperature, all will move here and there. Yes or no? So,
Yes, sir.
if you wanted to go from A to B, it will be difficult. So your conduction will hamper. Okay, or resistance increased. So because of the vibration of the molecules or vibration of the atoms inside the metal, it is increased by increasing temperature. That's why conductance will decrease. Clear? That's why conductance will decrease. Clear or not?
Yes, sir.
So next, so what is electrolytic conductance? Electrolytic conductance means simply electrolyte we are taking, and when you are adding electricity, what happens? Inside electrolyte, whatever ions, they will move. Inside electrolyte, whatever ions, they will move towards electrode. And because of this movement, because of this, anyone movement, the electricity will pass. Okay, and that conductance is known as electrolytic conductance. So you can write this, that the conductance of electricity by ions present in the solution is called electrolytic or ionic conductance. Okay, clear? Note down. that the conductance of electricity by ions present in the solution is called electrolytic or ionic conductance. Understood? Now, what factor it will depend, I'll discuss this. Noted? So, note down this. Okay. Now, what factor it will depend? So, first, I'll talk about temperature. See, you know that let's suppose you are making a solution. Okay, water is there, you are adding NaCl. Sometimes after that NaCl, it will become a saturated solution. It will become a saturated solution. Yes or no? But if you heat it little bit, again you can add NaCl. Again you can add NaCl. Why? Because whatever the solution, whatever the ions not dissociated, in presence of heat, it will dissociate more. So more heat means more dissociation. More dissociation means more conductance. So in this case, that problem in metallic conductance is gone. Like if you are using wire in your home, okay, you are using wire in your home. If temperature increases, and see in why in summertime there is more load settings are there. There more power cut is there. Why? Because high temperature, more resistance. Okay, the wire getting more getting more expansion is there, right? So more expanded, so that's why more resistance conductance will become low. But the thing is that in this case, if temperature you increase, more and more conductance is there. So we can use this for electricity, but for a large scale we cannot use. For large batteries, we will see about batteries. For large batteries we can use this. Okay, next thing is that another thing, the size or mobility. Okay, mobility of ions, size or mobility of ions. Simple thing, a small ion is there. Okay, small ion. Let's suppose lithium plus is smaller than sodium plus than potassium plus. Okay, small ion is there. Tell me who will run first? Smaller one will run first or bigger one will run?
Lithium.
Lithium. So ionic, so conductance of lithium plus will be more than sodium than K. So if LiCl is there, NaCl is there, KCl is there, who will show more conductance? Obviously LiCl. Okay, but this statement is partially correct. What? Listen, this statement correct when you are taking molten or liquid NaCl, LiCl. Because in liquid NaCl, LiCl, only Li plus, Na plus and K plus is there. But if you are taking aqueous, if you are taking aqueous, then what will happen? Then the smaller the ion, it will attach with more number of water. Okay, it will attach with more number of water molecule. Understood?
Yes.
So when lithium plus attached to it, let's suppose 8 molecule of water, and sodium attached to it 6 molecule of water, potassium attached to it 4 molecule of water. Tell me which size in water will be large? In water, which size will be large?
Lithium.
Lithium. So in water, aqueous solution of LiCl, this will be their order. Understood?
Yes, sir.
Okay. So that two factor is there. One is temperature, one is size. Okay. Size of hydrated ion will be conductance. Conductance will be low.
But can you repeat the same for the temperature?
Temperature means if you increase temperature, okay, more number of ions or ions increase, or more that interaction between ions will decrease. Okay. So so it will be conductance will more. Simple thing, simple. NaCl is there. If we heat it more dissociation will be there, yes or no? More
Yes, sir.
dissociation means more ion. More ion means more conductance. Okay. But in case of, if you are taking normal sodium metal, if you are hitting it, what will happen? Inside all the atom will move together. So electricity will not pass properly. Clear? So that is the difference.
Understood.
Understood? What are the factors affecting electrolytic conductance?
Yes, sir. Understood.
Note down, note down. Noted?
Yes, sir.
Okay, next. See, this is very important. Sometimes questions asked in boards that what is the difference between metallic or electrolytic conductance and metallic or electronic conductance or electrolytic and ionic conductance. Okay, this difference, remember. So you can write here that metallic conductance, if we increase temperature, resistance will increase, conductance will decrease. And here, if we increase temperature, resistance decrease, conductance increase. Clear? So this is inversely proportional, and this is directly proportional. None?
Yes, sir.
Okay. Next, tell me. Metallic conductance is due to
Electron and yeah, option A.
option A. Okay. Next, L.
Metallic.
Metallic will be there. Okay, why you are telling D? Resistance increase. Remember, resistance and conductance. I'm telling this also. Remember, you know Ohm's law. Do you know Ohm's law?
V is equal to IR.
V is equals to IR, right? Where I is current and V is voltage. So I is inversely proportional to I, R is on. So
Yes, sir.
I means current. So if resistance increase, current decrease.
Yes, sir.
So resistance also depends on directly proportional to length by area of cross section. Means if you are taking a wire who have 5 centimeter, and if you are taking a wire who is 10 centimeter, tell me where it will first electron will go reach faster there. Obviously 5 centimeter. So it depends on the length directly. And if you are taking a small wire and if you are taking a big wire, okay, electrons can go here easily than this.
Yes.
So if you increase, then resistance decrease, right? If you increase
Yes, sir.
resistance decrease, so R equal to A. So here you can write R equal to rho into L by A. Okay, rho is called resistivity or specific resistance. Okay, now 1 by R known as conductance G. This I'll talk about this more on it. Just simply I'm telling 1 by R equal to G. G is conductance. So 1 by R equal to G. So what should I write? 1 by rho into A by L is on. This
Yes,
1
sir.
by rho is known as conductivity, kappa, into A by L. Okay. So that's the thing. So resistance is inversely proportional to conductance. Okay. Till next question. C, and one answer I got C. What about Sarvesh?
So,
Tell. What answer? So, electrolytic conductivity, it increases as temperature increases. That is true. Okay. Next is experience a resistance due to vibration of the ion at the mean
okay.
position. Due to vibration of the ion at the mean position. Yes, that is true.
True.
It decreases strength of solute-solvent interaction increases. That is false.
False.
It involves chemical change. True. Chemical change is there. Yes or no?
Yes, sir.
Oh, wait a second. It decreases strength of, no. If solute and solvent interaction more, then decreases strength. Conductivity will be decreased. Solute solvent more interaction, then it will not go. The ion will not make. Yes or no? If ion is
Yes.
there, then only this is the there. If vibration is there, that doesn't matter in vibration. In electrolytic conductivity, we are not talking about vibration of the ions or vibration of the electrons. Okay, we'll only talk about the movement of the electrons and ions. Next, so this we learn. Remember this thing, concentration. Understood? Next, we are going electrolysis and application. Okay, so this I told you. This I already told, that selective discharge ion. Already told that increasing order of deposition. See, copper, see hydrogen, copper, silver, and gold. If aqueous solution not there, then they will deposit easily. And if aqueous solution also there, then this will deposit. Understood?
Yes, sir.
Now, in this case, what happens? See, SO4NO3, OH, Cl minus, bromine minus, I minus. So, if chlorine, bromine, iodine there, then they will deposit. But if SO4NO3 is there, oxygen will deposit in aqueous solution. If aqueous solution you are not taking, then they will deposit. No issue. Okay. So, note down this thing, very important. This complete point, very important. Okay. If you wanted to write the order, otherwise, simply, your electrochemical series, you can go with that. Okay, understood? Everyone? Tell. This is very important. Selective, how with selectively ion will deposit. Question will come in your board exam like that this salt solution is given. State what deposited in anode and what deposited in cathode and why. E naught value given. You have to write properly that it has lower SRP means standard reduction potential. Okay, lower standard reduction potential. That's why it will liberate at anode. Okay, liberate first at anode, and this have higher value of SRP, so it will be in cathode. Okay,
Yes, sir. Understood.
okay, understood.
Yes,
Everyone,
sir. Understood.
others, you can thumbs up if you have a problem. Okay, okay. Next, so here you can see if you take molten PbR2. Okay, molten PbR2 lead will come more than that. So lead will deposit, simple. Lead will deposit and bromine will deposit. Yes or no? Because molten we are taking. Similarly, molten NaCl, sodium will deposit and chlorine will deposit. Okay. But acidified water. Okay. In case of water, what will deposit? Simply, oxygen and hydrogen will deposit. Okay. Acidified water, oxygen and hydrogen. Remember this equation. Already I told you yesterday, last class,
Yes,
I
sir.
gave you this equation. At anode, what is the water equation? At cathode, remember how many electron we are using in anode? 4 electron. Okay. And cathode 2 electron. So when you are doing Faraday's law, you have to use 4 electron. Okay. E value when you are finding the equivalent mass. So oxygen equivalent mass, you have to do like that. So 32 by 4 you have to use. So 8 gram you have to use. Okay. Yes or no?
Yes, sir.
What was the Faraday's law? We'll go with that. Today also we'll recap that. Okay. Electrolysis of aqueous solution in NaBr, bromine. So NaBr, what will happen? Who will deposit? So bromine will deposit, okay, but sodium will not deposit. What will deposit? Hydrogen will deposit. Okay. So bromine will deposit and hydrogen will deposit. Clear?
Yes, sir.
Next, NaCl, same thing. NaCl, same thing. See, copper sulfate. Copper sulfate, what will happen? Copper sulfate case, copper will deposit. Okay, because copper is downside of hydrogen. Okay. Copper sulfate here, also copper electrode, all the things. Tell me.
Option B.
Option B. Anyone else? Tell. An electrolysis dilute sulfuric acid using platinum electrode. The product obtained at the anode. So anode means oxygen. Yes or no?
Yes, sir.
Next. Tell. The very important question. Tell me, who will deposit first? Four metal given. Who will deposit first?
Sir, option C.
Option C. Simply, who have high SRP? High SRP deposit first. Yes or no?
Yes, sir.
So who have high SRP? Obviously, C having high SRP. Then B, then D, then A. So C will play. Clear?
Yes, sir.
Understood, others? Understood? Then thumbs up. Put a thumbs up. Okay. Next, this question, write down this question, that in electrolysis of aqueous, this homework, your homework, okay? That in electrolysis of aqueous CuBr2 using platinum electrode, what are the product obtained at anode and cathode? Okay, and why? Why you have to write with reaction, proper reaction. Okay, note down.
Sir, will you send this PDF?
I'll send.
Okay.
Okay. Next, tell.
First one false.
First one, false. Okay, false. Second one, the current carrying ions in an electrolytic cell are not necessary discharge at the electrode. Yes, not necessary. Okay, not necessary. H plus is there, Na plus is there. Na plus will getting discharged. Okay, sorry, H plus will getting discharged, but Na plus having ions in there, not necessary. Yes or no?
Yes, sir.
So it is true, it is false. Okay, next, go ahead.
Sir, option A.
Option A. What about others? A. Okay, next. So A, simply cathode is negative in electrolytic cell. Next, which of the following reaction is possible at anode? Tell. Let's see. If you can tell, I can understood that you are in good position. Tell.
No, option B.
Option B. Why you told option B? There is something you thought about, like something is going oxidation, something reduction. So anode means oxidation, right? So
Yes,
you are
sir.
telling B is not possible. A is also oxidation, right? Yes, on +3 to +6. 8 also oxidation. They are asking possible, not impossible. Which is possible. I don't know. A is oxidation. Okay. B is reduction.
Yes, sir.
So answer should A, right? Yes or no?
Yes, sir.
But actually, if you are using water and chromium is more than water. So how it will be go in the anode side? Understood?
Yes, sir.
So actual answer oxidation. Okay, and think I'm telling that. Okay, actual answer oxidation possible in anode. So this is the oxidation. So this will be the answer. Clear?
Yes,
Next.
sir.
Tell.
Option B.
Option B. Anyone else? Copper liberated at cathode and oxygen as anode. Next.
Option A.
Option A. Okay. Clear? Both will be there. Okay. Copper deposit at cathode and copper dissolve at anode. Dissolve means copper will become copper 2 plus. Yes or no? If you are
Yes,
taking
sir.
both the copper electrode, if you are taking platinum electrode, okay, deposit at cathode, okay. But copper you are taking as a anode also, right? Yes or no? So it will dissolve. Next. Faraday first law, I told you, W is equals to ZIT. Okay. W directly proportional to I into T. And how to find out Z? Z is nothing but equivalent weight. Okay. How to find out equivalent weight? That reaction number of electron what you are using. Okay. That is called N, and molecular weight by N. So overall equation, what is that? W is equals to molecular weight into I into T divided by N into Faraday. Okay, this was the final equation. Remember this thing. Directly you can find out. Okay, what is M? M is molecular weight of metal. Molecular weight of the electrolyte or metal. Molecular weight of metal. Generally, we are talking about metal or gas, whatever depositing. Okay, whatever depositing, that molecular weight. If chlorine depositing, then Cl2 molecular weight. Okay, oxygen depositing, O2 molecular weight. Copper depositing, copper molecule. Okay, so like that, here silver depositing. So silver having one electron, so you have to divide it with one, and that you have to do. Fluor A5 told you what is Faraday. Faraday is what is Faraday? 1 Faraday means the charge carried by 1 mole of electron. Okay, charge carried by 1 mole of electron. So charge carried by 1 mole of electron, that is value is 96500 coulomb. Okay, so directly you can do current efficiency. Current efficiency you actually don't have. Let's go. Tell.
So, but they gave us extra questions based on the
Efficiency.
yes, sir.
Simple efficiency means whatever the calculated value. Okay, you calculated the W na. Okay, and some experimental value given. Actual value. Actually you are getting. So multiplied with 100. That is efficiency percentage, or if you are not multiplying, then current efficiency. So whatever, let's suppose you are getting, you should get 80. but you are getting only 60. Okay, so your efficiency will be 75%. Understood? That battery efficiency is 75%. Understood? Yes or no?
Yes, sir.
Now you will tell, sir, why we are calculating by mass? Simply we know Faraday told that W directly proportional to charge current. Yes or no? So whatever mass deposited, charge also same. Okay, go ahead. These are JE questions, but nowadays these are previously easy JE questions. Okay. Next day we'll do some boards questions. Go ahead. Tell. One more thing to tell you. Next week, mostly Tuesday class will be not there. Tuesday class will be Wednesday, and you have holidays, right? So I'll take most morning class. Okay. I'll also going to hometown. So I'll take morning class. Okay. Next 2 week or 3 week will be morning classes, and some extra classes will be there. I'll inform.
Okay, sir.
Sir, but about the Wednesday evening class, I'm not sure, sir, because
Evening, not
Aditya,
evening, morning.
okay, sir.
Wednesday will be there. It will be morning. Okay.
So in May month, so no evening classes.
I'll tell. If evening is there, I'll tell. Morning is there, I'll tell. Okay. But next Tuesday, there will be no evening class. Morning class only. Okay.
Yes, sir.
Tell me this one. See, electric current passed through this much ml of hydrogen gas. This much ml of hydrogen gas at HTP was collected at cathode. Okay. In 965 seconds, the current passed in ampere. Simple thing, simple formula. Remember, W is equals to M into I into T divided by N into 96500. Right? Yes or no? This thing you remember. Now, listen. 112 ml. 112 ml means, what do you mean by 112 ml? 112 ml in STP means how to find out? How to find out moles? Volume at STP given divided with 22.4 liter or 22,400 ml. So this is 1 by 200. So 1 by 200 mole. So 1 by 200 mole of hydrogen means how much gram of hydrogen? 1 by 200 into 2. That means 1 by 100 gram of hydrogen. Yes or no? So W value I got 1 by 100 equal to M value. What is the hydrogen mass? 2. Hydrogen mass 2. And divided by what is the N value? That is also 2. Multiplied with 96500 into I they are asking, and last is 965. So this also 100. 2 and 2 cut. This cut.
Yes.
I value 1. Okay.
Yes, sir.
That's simple. Okay. Formula very important. Remember that thing. Okay. Either you go, see in boards you have to write like this. Okay. Either you can go like this, or direct formula you can write also. No issue. Direct also you can write the formula that W is equals to, you can write according to Faraday's law. W is equals to Q. W is equals to Z into Q. Okay. Z is equals Z into I into T. Then this Z is equals to your molecular weight by N into I into T. That's it. Then put the value directly. No one can cut your marks. Next, try. So this will be your homework. Okay, this will be your homework. Try and tell me next day. Clear?
Okay, sir.
Boron means B2H6. So this some questions are there. This will be homework. You will do. Tell me, understood or not? All
Yes, sir, understood.
second law also we have discussed. The W1 by W2, E1 by E2. Okay, equal to M1 by M2, N2 by N1. That also we'll discuss that. If you connect to two cell, okay, and two electrolysis will be there some copper will deposit, there some silver will deposit, okay, but they will deposit in same manner. What will be the ratio? That W by E ratio will be same for both. Okay, W by E ratio will be same for both. So some questions are there that will be also for your homework. Do that question. Okay, next day I will see. Clear?
Okay, sir.
Next day we'll start conductance. That is the last topic. Okay, last topic. We'll complete that. Any doubt?
No doubt, sir.
Tell me any electrochemistry. See, electrochemistry is quite lengthy chapter. Okay, and kinetics will be easy and easy to remember, easy to do the sums. Here, what you have to do more theoretical part. Sometimes questions will be theory and question calculation based questions will be there. Okay, conceptual questions are there. Okay, two question will come in from electrochemistry. Two question will come. Okay, one is from electrolytic cell and one is from voltaic cell. Voltaic cell Nernst equation question is there, or if Nernst equation question is there, or any conceptual question will be there. And in electrolytic cell, from Faraday's equation will be question will be there, or any cell question will be there. That you have to do. Here.
Okay, sir.
Okay. Okay, so read that portion. Read that portion from NCERT. Especially, I'll tell these questions are secondary. First, go and do the NCERT question. NCERT grade 12 book question. That is the first priority. Okay, first priority you have to do. I don't know, you are not asking any doubt from this. You should ask. I want that query from you that this question is doubt or not. This is the thing. Okay, this portion in NCERT is the okay. Daily read whatever I am teaching. Read that portion in NCERT. Okay.
Okay, sir.
Okay, then we'll meet in the next day, Thursday. Okay, then. Bye.
Thank you, sir. Bye, sir.
Thank you.